Alright, so next video, we're going to start with, I'm going to introduce while statements. And so to show you how a while works, I'm going to make the computer count for me. So I'm just going to do a basic input, and I'm going to ask the user how many times we want to tell the computer to count. And then we're going to throw that into the while statement, and it's going to count however many times we tell it to count. So to start this off, I'm going to open this up, set up the usual stuff. Pooh can explain a little bit about how while statements work and just like some general stuff about while statements.
Okay, so I'll explain what I really want to talk about while statements once we're done with the little sample program. But I'll talk a little bit about what we usually use a while for. A while for is used when you have a condition to test and you don't know when you're going to stop. Somewhere inside of your while loop, you're going to change the initial condition that was presented to go into the while loop so you can break out. So what we're going to do is we're basically going to show you a little counting program, and the program is going to keep outputting the numbers as they keep incrementing.
Yeah.
Each iteration of the while loop, and the condition is going to be false at some point. You want to change the condition somewhere inside of the while loop, because if you don't, you will get something called the infinite recursion, or it's not infinite recursion, it's an infinite while loop. There we go. Which is when you get stuck and you can't stop, and you're just looping forever.
Yeah, you just keep looping and you never break out, and your program keeps going until you tell it to stop or something else happens.
And the reason for that is that the while loop is kind of like an if statement that keeps repeating itself at the end.
Yeah.
So the while statement will check the condition once. If it is true, it will execute. If it's false, it'll just skip it. But if it's true, it'll do all the code that is within the curly braces, brackets. Which one? Brackets. Curly braces, whatever. Thingies. It'll execute the code once, go back to the while, to the very top of the while where the Boolean statement is, which is our condition, check it again. If it's true, it'll do it again, and so on and so forth. That's why you want to change the condition inside of the while loop. Otherwise you get stuck, because once you're in the while loop, you don't change the condition in the while loop, it's always true, you're stuck. The only way to exit out of that is by killing your program, by sending a kill signal with Control Z or Control C. Control C, right?
Yeah.
Control C, yes. Okay. So we're basically asking them, how far do you want us to count? Well, I guess a computer to count. And we're going to test while number, I guess, is bigger.
Yeah.
Than count.
Yeah. Well, I'm going to say the opposite way.
Well, count less than number. It's same thing.
Yeah, same test. You can think of it's the same type of logic that you use in an if statement, and you just carry that over to your while statement. So you read that while count is less than number, we're starting our count at 0. So it's always going to be 0, and is 0 less than whatever they enter, so hopefully they enter in something greater than 0, or else it's not going to be executed.
The reason why Kevin had to initialize the variables is because if you don't, count might have some sort of hoopla in it that somehow magically manages to translate to something bigger than number, and the while loop does not work correctly.
Exactly. So here we're just gonna probably just increment the count, and then
see out the number first, and see out count first, and then let's increment it, so we can see how it's incremented slowly.
Okay.
Count plus plus, by the way, increments count. By
yes.
1. It adds 1 to it. It's the same thing as count equals count plus 1.
Yeah, so you can write this in count equals count plus 1, or count plus equals 1. All three of these ways are the same for incrementing 1.
And then there's plus plus count, which is,
yeah.
I don't know weirdo property it has, but I never used it before.
We can show that, but that's probably for a different time.
Yeah.
It's
Okay.
postfix and prefix. So yes. So that can be it for our while statement.
Once again, as you can see, we're changing. What is this thing?
I'm just gonna slow it down. I think I can do this.
Sleep 1?
Yeah.
Sleep. Isn't
Make
it
sleep 1
milliseconds?
seconds. No, that's you sleep.
I thought it was milliseconds.
I don't know. We'll find out.
Wait. Okay. 1 second.
I probably need to include something for this. But I
Yeah,
don't know.
probably. Anyway, you don't need to know what sleep does, even though sleep just makes the computer.
I'm just using this for the code.
Yeah.
For this particular thing, you don't have to pay attention to it.
It'll slow it down so that it doesn't spew out a whole bunch of numbers at us instantly. But as you can see inside of our while loop, we are changing count. The part where we change count is count plus plus. So that is actually changing the initial condition because count keeps getting incremented. So eventually, it'll reach a stopping point in which count is bigger than number, and we will break out of the while loop because the condition will be false, and we will return 0, and the program will be finished. If that count plus plus was not there, we would enter endless recursion of time.
Exactly. So I'm just going to break down how the while statement is going to work. I'm sure I've done it before in past video, but what it's going to do is it's going to test this line right here. It's going to go into this inside of the parentheses and make sure that this evaluates to true. If it does, then it's going to go and execute this line, and then we're going to just fall down this line, this line, this line, and then when we get to the bottom of our loop, we're going to go back up to the top and check our statement again. And if it's still true, we'll start the process all over again from the top, and we'll go down again, and we just keep doing this circle until this statement evaluates to false. So hopefully I did this right, and I can show you without any problems.
Impossible. It's wrong.
Yeah, impossible. I'll probably need to include something weird. If not, I'll just take it out for the sake of the video.
What's that library that has the system calls?
Oh no. Okay, so there's no problem.
Oh wow.
Because I'm pro, and Poogie didn't believe me. Yeah. So let's run it real quick. So how far do you want me to count? So we want to tell the computer
40.
count to. We're not gonna sit here for 40 seconds.
Oh.
Yeah.
Oh, are you sure seconds? I think it's okay.
Well,
whatever.
We'll find out.
Whatever.
I think it's seconds.
Okay.
So
Okay.
let's tell it to count to 10. So let's hit enter.
It is 1
so
second.
it is a second. So we're just watching it count to 10, and it started at 0. Well, actually, it's gonna count to 9.
Oh, that's right.
Because
it's non-inclusive.
Yeah, because of the way that we did the statement. So if we go back, if we go back and look at it, it counted from 0 to 9. As you can see, we started our count at 0, and we are doing from count less than number. So is when we get to 10, is 10 less than 10? And that's false. So that's why we didn't print out 10. We can change this to a 1, and then we can change this to an equal sign. So this way we can start at 1 and end at 10.
By the way, we haven't gotten up to that part yet, but computers count starting at 0. But we'll get to that when we get to that.
So I'll just go ahead and rerun this real quick.
10.
And we'll put in 10. And then you see we started at 1 because we set it to 1. And we're counting every 1 second. And when we get to 10, it should break out. There we go.
We should have sat here for 40 seconds just watching the numbers go.
Yeah, we could have. We could have. You can do that next video, Puga. So that's an intro to while statements, and we'll have another video, and we'll talk about do while statements, and we may do another example of while statement. All right.
Okay.
Bye.